Okay, so I want to do a example from the homework here. This is just the first homework problem. A couple of you had questions here on the two-tailed task and the percentages here. So let's just kind of walk through this one. Nationally, about 11% of the total U.S. wheat crop is destroyed each year by hail. An insurance company is studying wheat hail damage claims in a county in Colorado. A random sample of 16 claims in the county reported the percentage of the wheat loss to hail. Now, here's what you want to notice is the data is not in decimals. This is 14%, 10%, so they did not change it to decimals. Let X be a random variable that represents the percentage of wheat crop in the county lost to hail. Assume that X has a normal distribution with sigma equal to 5%. Again, they didn't change it to a decimal. Do these data indicate that the percentage of wheat crop lost to hail in that county is different either way from the national mean of 11%? Use alpha of 0.01. Okay, so a couple things we want to notice is we know sigma, right? So since we know sigma, that's going to tell us what kind of test to use. Yep, that's right. We're going to use a z-test. If we know sigma, we use a z-test. If we don't know sigma, we use a t-test. Okay, if it's given us talking about proportions, then we use the proportion test. So anytime it gives you data like this, it's either going to be a z or a t-test. Again, to know if it's a z, you have to know sigma. Okay, so now let's set up the null and alternative here. So when we look at the alternative, we look at, do these data indicate that the percentage of wheat crop lost to hail in the county is different either way? Okay, it doesn't say more than or less than, so that's determining our alternative. And since it says different either way, we know that's going to be not equal to. Now, the national mean of 11%. Again, because the data are not changed into decimals, you just want to leave this as 11. If the data had been 0.14, 0.10, 0.08, 0.12, then you would have put 0.11 here. Okay, but because it's not, you want to just do 11. Okay, and therefore the null is just equal to 11. Okay, so this makes this a two-tailed test. Let's screen a little bit there, sorry. Okay, not right-tailed, it's not left-tailed, it's a two-tailed test. Because of that not equal to. All right, so now step 2 is getting our z-test statistic. So let's go to our calculator here. And we're going to go to stat, into edit. Okay, now you can see here that I already have my list in here. So if you want to hit pause right now and go ahead and put this list in just to follow along, go ahead. And do second quit. Then we'll do stat over to test. Remember the very first one, since we know sigma, we're using the z-test. So we'll hit enter. We're going to choose data. Now, if you had stats here, go ahead and put the cursor over data and hit enter. New not then is what we have in the null, so that's 11. So go ahead and put 11 there. Our sigma we know is 5. Again, leave it as 5 because the data is not as decimals. And choose L1, leave frequency 1, and you're going to choose not equal to here. And we are going to go down and hit calculate. So we get a z-test statistic of 1.5. Everybody good with that so far? Okay, so step 3, we're going to draw that picture. Because I have my calculator up, I'm going to actually go over here and write for my step 4, my p-value. I always, instead of just writing p, I write the word p-value so when we get to proportions, we don't get confused. Even though the calculator just gives it to us as a p, I always write p-value. So that p-value is 0.1336, right? Okay, so for our critical region, and this is with some of the questions here, because it's a two-tailed test, we are going to have a rejection region in both tails. Okay, now remember the rejection region is determined by our table. Okay, so we're going to go to the table. We're going to go to the table. Okay, we're going to go to the table and we're going to look up, because we know alpha is 0.01, and this is a two-tailed test, where those intersect, it's plus or minus 2.58. Okay? Okay, so on our graph here, the right side is the positive 2.58, and the left tail here is negative 2.58. That means this is 2.58 and this is negative 2.58. Remember, the center is 0. Okay? So what we're looking at now, so this determines where our rejection region is. Now think of this as a number line. Here's 0, here's positive 2.58. So the question is, where does our 1.5 fall? I'm going to draw in 1.5. It's not greater than, it's not to the right of 2.58, right? Our 1.5 falls in between 0 and 2.58, right? So I'm just going to go ahead and draw that in right here. A lot of times we'll write it up top. And I like using a different color ink like this because it shows you. Now, the question is, does this test statistic fall in the shaded area, the rejection region? No, it does not, right? Because we say no, then our decision is do not reject H naught. Remember to put H naught on there. Okay? If the Z test statistic would have fell to, if it would have been larger than 2.58 or smaller than negative 2.58 and it fell in the rejection region, then the question is, does it fall in the rejection region? We would have said yes, and then our decision would have just been reject H naught. Because we say no, it's not in the rejection region, we do not reject H naught. Make sense? Okay, then the p-value approach. Remember, our statement here is we're going to reject H naught if the p-value is less than or equal to alpha, or 0.01. So our question is 0.1336 less than 0.01? Less than or equal to. Okay, so no, it's not. Now, if you're not sure how to do this, I think I showed in the video, we add the number of zeros so that we have the same decimal place values. And then we cover up this and just look at the number. Like this as a number would be 1,336. This as a number would be 100. That 1,336 is clearly not smaller than that. So again, our answer is no, which means we do not reject H naught. Okay, so our two decisions here have to match. They have to be the same. Okay. Oops. So then our step 5, because I'm running out of room, we're going to say at the 0.01 level of significance, or we could say 1%, okay, we either say we do or do not have enough statistical evidence. So again, we go back to look at our decision here. We only have enough statistical evidence if we rejected the null. Since we did not reject the null, we do not. Remember, the nots go together. Okay, not, whoops. Not. Okay, we do not have enough statistical evidence to conclude that. Now again, this is where we kind of go back and look at the problem and look at the question. It said, do these data indicate that? So we're going to follow the words after that. At the 0.01 level significance, we do not have enough statistical evidence to conclude that. And then we're just going to use these words here. The percentage of wheat crop lost to Hamilton County is different either way from the national mean of 11%. Okay, makes sense? Okay, so I ran out of room, as you might too. And that's our 5 steps. Okay.